Hello, we are the Weather Boys and we decided to adopt Challenge 7. We are Mihai, Mohammed, John and Matt. Challenge 7 centered around HS2 and how they could use a greater understanding of weather to optimize how they deliver their construction projects and manage assets. And the real benefits we were looking to provide was helping to manage the decision-making process to optimize for productivity, cost and safety. First, we looked at the end users that are affected by changes in climate. We chose 3 key stakeholders at different levels of the project delivery, representing 3 different opportunities to deliver on the brief. The project director, for instance, is reviewing projects at a portfolio level and wants to understand how they can resource projects to optimize delivery. The project manager is concerned with medium-term planning on the project. What does the next week look like, and how can I reschedule work to meet all of my milestones? Then finally, the site operative is concerned with optimizing the plan for today. Can I undertake the task that I've been set? And if not, can I rearrange the day's work? We decided to build on this concept and deliver 3 separate but linked front ends that provide insights at each level. First, in order to support the project director, we gathered information from weather stations across the entire line of route, and based on safe working information, we can rank each project based on how impacted it will be by the weather over a given date period. This includes restrictions on crane usage, concrete pouring, and groundworks. With each site ranked, the project director can understand the upcoming work across the portfolio and where best to spend resources. Next up, the project manager, who needs to ensure that the work is being carried out efficiently and safely on site. With this dashboard, they can see the weather impact across multiple activities, hour by hour, over the coming week. This provides an immediate health check on the status of their project and will allow them to reschedule teams accordingly. Given that a gang of labour costs approximately £200 an hour, with 10 gang hours saved across 20 projects each week, that would result in £40,000 of savings per week. Where the project manager does see an issue with a particular activity, they can drill into that particular time frame and see the specific weather statistics so that they can include their own judgment in any decisions. Finally, the site operative is at the workface and trying to understand how best to deliver the day's work. The app we have built, Empower Apps, allows them to identify their workface and at a given time see whether they should expect weather changes that will affect their delivery. Site operatives also have the opportunity to record their own weather observations. When looking at the data, we noticed that the restrictions were very rigid and it was not clear what the basis of the calculations were. By allowing users to record their own issues on a daily basis, we will create a rich data set which can be compared to the weather to build out a more accurate restriction model in the future. As well as this, in the future, wind speed could also be directly linked to crane telemetry to alert the driver when high winds are predicted, and also push notifications could alert app users if weather restrictions are expected to occur throughout the day.
Implementation tomorrow. We have identified our end users' pain points with care. Given the poor condition of existing project data, such as programs, we have elected to build our platform with no data prerequisites. All you need to do is to update your safety requirements so the system can understand when the weather exceeds safe levels and informs the end user. For example, a heat wave has been categorized as a period of at least 3 consecutive days with daily maximum temperatures meeting or exceeding 25 to 28 degrees Celsius. When daily maximum temperatures exceed heatwave conditions for the given locations, workers need an additional break. Structure. Data has been compiled using open standards, combining provided site data with data from the Met Office API. Built with the expectation that this will be an ongoing automated system, live projects can run scripts daily to populate your database, and every additional on-site weather station will create a more accurate solution. Machine learning. We can forecast the wind speeds and directions for different seasons across a number of years. From these, we can predict trends for a given season and find insights on when certain project work can take place.
How have you managed combining data from different sources? The data sources that we had were from the client, the Met Office, and data from Google Maps. The data from the client was the extreme weather threshold data, data from on-site from different weather stations, and from the Met Office, that was the weather daily, hourly, and 3-hourly from the API. We gathered longitude and latitude data from the Google Maps API. The aforementioned data was loaded into SQL and normalized. The client on-site data previously, before this, was normalized in R, where it was cleaned. And normalization just means making sure all the names are the same and agree with each other from the different data sources. The coordinate data was then plotted using an HS2 custom Google Map image and associated to the weather info that we had from the R data, the weather threshold, and the Met Office API for machine learning. How would the system deal with a big difference in the weather data from the Met Office and on-site sensors? Would it prioritize a particular data source, and why? One way that we could deal with the difference is to look at another source of weather for comparison. Would it be easy for a new site to be added to the dashboard in the future? What would this process be? Currently, a new entry has to be loaded into the database with a new integration from their project management system to load into our SQL database, and thus we can add a future worksite coordinate. The R process would then need to be rerun in order to include the weather data points on site and loaded into SQL in order to map to these future worksite coordinates. As long as the existing formats are adhered to, weather mapping will work as intended.